Hey, what do we got here, man?
Well, we have a nice Rolex watch.
Yeah, that doesn't look real to me.
Oh, it's 100% gold and some silver.
I think I need to check the densities on that one.
No,
See if it's made
man.
of real gold and silver.
It's fine. It's real.
Here, come with me. I'll show you what to do. Alright, man. First thing you got to do to find the density of any object that sinks. You need to find the weight of the object in air and the weight of the object in water. That's it. So,
Yeah, Craig!
weight of the object in air.
Craig! Woo! Cheap for 'em. Yeah.
How much?
It's about 1 Newton.
1 Newton. So we got weight in air equals 1 Newton.
Yeah.
Now we need to find the weight in the water.
Yeah, Dick.
Cup of water.
Keep filming, Dick.
Put it on the scale.
How much?
It's about 0.75 Newtons.
0.75 newtons.
Why do you have my mug?
Weight of water.
Yeah,
Why
Craig.
do you have my mug, darling?
Craig. They
All right.
mug me up my mug.
And the second thing that you have to know for physics is the density of the water is
Yeah.
You
always
mug me.
Yeah, Nick.
1,000 kilograms per meter cubed.
1,000. Armpit hair.
Oh, okay.
It's
I think I
the
get it.
rest
So
of your
weight
fingernails.
equals mg, and if gravity equals 9.8 meters per second squared,
It's local.
that means the mass has to equal 0.102 kilograms.
Exactly.
Nasty, JT.
Did you see his
So
width from the throat
nasty.
too?
Did you see?
Through-
Alright, we need to draw a free body diagram of the object suspended on a scale in water.
Okay,
Darby always makes a rude looking face.
he walked in front of Coach. Coach got just like that.
Oh, you did better than your
Alright,
brother.
and we use Newton's second law of motion, which is the summation of forces equals ma. So we got
1025.
tension force
25 seconds. I just agreed with my
equals 0.75 newtons.
I do like that.
And then we got
Yes, I do.
the weight and we got the buoyancy force. Alright, so because there is no acceleration, this cancels out and it's going to be the summation of forces equals 0. Because there's no acceleration, as I said. So we're going to solve for B, the buoyant force. B equals B times V times G. Alright, we're going back to Newton's second law of motion. We set the force equal to 0. So we got the free body diagram of the watch being weighed in water. We got the tension of the water, the tension of the scale in the water, minus mg plus buoyancy. So now we can set this equation equal to buoyancy equals mg minus the tension of water. Alright, and now we go over here and draw a free body diagram of the watch in air. And we got the tension in air and mg are the only forces here. So we go tension of air minus mg equals 0. Therefore, the tension in air equals mg. So now we come back to this equation and substitute T air in for mg, and we get that the buoyancy equals T air minus T water.
Guess what?
Therefore, the buoyancy equals 1 Newton minus 0.75 newtons. That's equal to 0.25 newtons. Now that we have found the buoyancy, we need Archimedes' principle.
Okay, so 0.25 newtons equals rho, which is the buoyancy or the density of water. So it's 1,000 kilograms per meter cubed times volume times gravity, which is 9.8 meters per second squared.
You sound like you feel betrayed.
I do. Yes.
Okay, so now we can solve for volume. So it ends up being
Everything you said. And he was a good coach. We
Point
won games.
25 newtons equals 9,800 kilogram per meter squared second squared. Meter squared second squared times volume. Okay, so then you divide 0.25 by 9,800 and you get 2.5 times 10 to the negative fifth meters cubed. And that equals volume. And we know that density equals mass over volume. And we have both of the variables. So the density is equal to 0.102 kilograms over 2.5 times 10 to the negative fifth meters cubed. And that equals the density. Okay, and that is equal to 3.99 times 10 to the third kilogram meter cubed. Okay,
Very good. You're a fast
so
learner.
I'm not quite sure what that tells us.
Here,
That's
I'll
the
explain. Alright, in explanation of what you just found, we found the density of that watch. So, now let's compare it to some densities of other metals. Alright, so he tries to tell me that this is made of gold.
It's gold.
Well, Siemens is the density of gold is 19.3 times 10 to the third. That's not anywhere close to this density, so it's obviously not gold. Now, you said it may be silver? Well, silver is 10 to the fifth.
It's all
10.5 times 10 to the third. So it's clearly not silver either. What it is, it's closest to aluminum, which is 2.7 times 10 to the third. So after we subtract the weight from this plastic head cover and all the inner workings inside this watch, we're going to get about 2.7 times 10 to the third density. Therefore, it is going to be a counterfeit Rolex made of aluminum. Alright, so now we're back where we started, and we discovered that this is definitely a counterfeit Rolex. So, do you feel at all guilty for trying to convince people that this aluminum watch is made of gold?
Well, I've run the numbers, and instead of charging $1,000, I think now is to charge $950.
Consider it a deal, my man.
There you go. Be happy.
Awesome.